In this video, we're going to discuss CRA models for rational exponents or roots. Okay. So in kindergarten through 8th grades, we're not really using this exponent form, but our roots, what we're doing is just square roots and cube roots. There's other roots. So this is our root form. Okay. So we have under this radical symbol, that's this kind of check mark with a roof type looking thing on it. That's radical symbol or root symbol. A here is called the radicand, and then X is the index number. So all this means is that we're taking that A to some fractional or rational exponent. So if we were to have the xth root of A, we could rewrite that as A to the 1 over x power. Okay. So for example, a lot of our, if we do the square root of 5, if we wanted, we could write this as 5 to the 1/2 power. Okay. Or if we had the cube root of 7, we can write this as 7 to the 1/3 power. So we're just going to look at roots, and we're only going to look at square roots and cube roots. So notice you don't need to, this x, again, that's that index number. We don't generally write the 2 in there if it's the square root. So if this is empty, it's implied that that's a 2. There's kind of an invisible 2 right there. If it's anything else, then we will write that number in there. Okay. So before we jump in to just a couple examples, again, the K through 8 exploration of rational exponents isn't incredibly deep. We're just looking at square roots and cube roots, and often looking at perfect squares and perfect cubes. So kind of how we can conceptualize this at this stage is if we have the square root, so say we're taking the square root of n, how we can interpret this is using a geometric model. So if we see this, what this is telling us is we're looking for the side lengths of a square where the area is equal to that n number. Okay, and kind of similarly for the cube root, so the cube root of n, what we can think of as we're looking for the edge lengths of a cube where the volume is equal to n. Okay. So we'll just look at a couple examples here in that geometry model. Okay, so if we have the square root of 9, okay, so again, how we can interpret this is we have a square with an area of 9, so we have 9 square units, and we want to see what is the side lengths of the square made out of these 9 parts. Okay, so most of us probably know that it's going to be 3 by 3, but if we don't exactly know, right, we can kind of try to line things up and see. Right, you might have to kind of shift things around a little if it's a student that isn't quite sure. Right, but eventually we'll settle on, right, there's only one square we can make with 9 square units, and it'll be a 3 by 3. Okay, so then our solution to this is what are the side lengths of that square with 9 square with an area of 9 square units. Side lengths will all be 3 for that square. Okay. And then representational model, right, might not necessarily use a whole lot, but essentially what we're trying to figure out what the side lengths are. And then abstract model at this stage is we're really just using the radical symbol. Here we don't have an index number, and then our radicand, and then our solution there. So that's the square root, and then last one we'll look at is going to be the cube root. So again, how we can kind of think of this at this stage is that geometric model. So if we have cube root of 8, what this is saying is we have a cube that has a volume of 8 cubic units. And we want to figure out what are the edge lengths, which is just the term we use for the side lengths of a 3-dimensional figure. So again, we'll know we need some cube. Okay, so we'll have to start kind of stacking vertically because we want this to be three-dimensional. Again, there's probably not a lot of, especially for this example, probably not a lot of different options for this. Again, so a cube has to have all the same, faces, same side lengths. Okay, so we can see that we made a 2 by 2 by 2, it's falling apart a little, 2 by 2 by 2 cube. Okay, so then again, our solution, right, we're looking at if we make a cube that has a volume of 8 cubic units, which is what we did, what are the edge lengths or the side lengths? You can see that it's a depth of 2, width of 2, and a height of 2, so the cube root of 8 is going to be 2. Okay, and again, the representational models probably aren't going to be used a whole lot. Right, if we wanted, we could show that there's, right, we can see the 4 on the front, we can see there's a 3, we just have to know there's one back there. So there's a total of 8 cubes in there, and then this has all of our edge lengths that are 2. Okay, so again, kind of using the geometric models to conceptualize the square roots and the cubic roots here.